All right, so let's take a look at example 1. We want to rotate the region enclosed by 2x squared minus x cubed and y equals 0 about the y-axis. So let's go ahead and sketch our region here. So, oops. So y equals 2x squared. In order to sketch this very accurately, we probably need to factor this or something. So this would turn into y equals, let's say, x squared times 2, the quantity 2 minus x. Okay, so this is a cubic. It begins upward and ends downward. So this would probably do, it has an x-intercept of 2, and it's got a double root at x equals 0. Since it's the double root, it should do something like that. This should go up forever, and this should have something like this. So that is what y equals x squared times 2 minus x looks like. So this is 2. So rotate the region enclosed between that and the y equals 0. So we are going to be looking at this portion just right here. Okay. So if we're rotating this about the x or about the y-axis, then what we can do is think about drawing a representative slice. Unlike with discs and washers, you draw your slices perpendicular to the axis of rotation. For shell method, we draw them parallel to the axis of rotation. So this is the piece that will get rotated over here. And that's what's going to create that volume. So if you draw your shell, you can see that this represents the height and that this distance here to your shell, that's the radius. You don't have to draw all that stuff. I generally don't draw that all, but I do draw it at the start just to get an idea of what's going on. So I draw my slice parallel to the axis of rotation, label it with h since that's what the height is, and then this distance from our axis of rotation, of course, that is our radius. So our height appears to be the y value, which is x squared times 2 minus x. And then the radius r, that should be, well, if it's measured from the y-axis, then that means we're allowed to call that x. So for shell method, the formula is the 2 pi times the integral from a to b, our radius times our height. And rotating about a vertical axis, we integrate with respect to the opposite variable, the horizontal variable. So with discs and washers, there's this notion of sameness. If you're rotating at a horizontal axis, you will integrate with respect to the horizontal variable. Where when it comes to shell method, it is an opposite sort of phenomenon. If it's a vertical axis we're rotating about, then we would integrate with respect to the horizontal variable. So that's why having both of these techniques at our disposal, I should say, makes us very good at solving a wide variety of problems. Because if it's not going to work well for one method, we can sort of interpret it in this opposite manner using the other method, and that hopefully gives us some flexibility. So for us, since we're integrating with respect to x, we're going to go from 0 to 2. So this volume integral set up is 2 pi integral 0 to 2, the radius, which is x, times our height, which is x squared times 2 minus x dx. And of course, we're just setting these up. Okay. Let's take a look at another one here. Let's do two examples in this video since that one was pretty quick. Example 2, let's rotate the region enclosed by, so we've got this parabola that opens rightward. It opens rightward. So this would, let's go ahead and sketch our XY plane here. And let's go ahead and draw my other axis like that. Okay. So x equals 2, we'll sketch that last. So for now, we've got this x equals 1 plus the quantity y minus 2. So this means we're going to start with an x value of, let's say, well, this is written in vertex form, I believe they call it. So we know that the vertex is, let's see here. I believe this would be 1, 2. That would be the vertex. So let's go ahead and draw this at x equals 1. I'll say x equals 1 is there. So then let's say 2 is right up here. And then this would open rightward, so this should be something like that. And then x equals 2, of course, would be just like that. Okay, so now that we have that done, we can move on with the shell method. So we found the region that's enclosed. It's this highlighted in blue region. And this is going to be rotated about the x-axis. Okay. So again, shell method, this means we are going to go ahead and draw a slice, a representative slice within our region that is parallel to the axis of rotation. The radius is always measured from the axis of rotation. So since our axis of rotation is the x-axis, this radius is just y. Anything measured from the x-axis, we are allowed to call that y. And then this length, the length of this line segment, h, that is the height of our cylindrical shell. So height. So the height in this case would be the x value at the right end, so 2, minus the x value at this end here. Well, the x value here, this is what, well, we're thinking about drawing this at some representative y value. So this is just some y value we're at, and we want to know what is the x value here at this endpoint, this left endpoint. What's the x value here? Well, the relationship between x and y on this curve is given by this. So if we want the x value, then it is going to be 1 plus y minus 2 quantity squared. So that is the height. It's the difference in the x values, right minus left. So our volume integral for shell method, if we're rotating about a horizontal axis, is 2 pi the integral from a to b, radius times height, but this time we'll be integrating with respect to y. Again, there's that opposite phenomenon. So we want the minimum y value, which is wherever this intersects. So we have to find out this intersection point. Okay. So we can find this intersection point by solving. So we could set this equation equal to 2. So we can have 2 equals 1 plus y minus 2 quantity squared. 1 equals y minus 2 quantity squared. Square root, so we get plus or minus 1. Y minus 2. So y is 2 plus or minus 1. So this is 1, and then this other point of intersection up here, that would be 3. So this picture is not drawn to scale. So I'll just move up my 1 a little bit. Here we go. Okay. So this would be from 1 to 3. Our radius, which is y, times our height, which is 2 minus the quantity, 1 plus the quantity, y minus 2, quantity squared, and then close those other quantities. So that's the shell method set up for that one.